Chapter 7 is our new guy. Chapter 7 is basically techniques for integration. Right now, we know how to integrate things if they are standard integrals. So I know that the integral of e to the x is e to the x, right? And I know some ones like secant squared, and I know the power rule. And that's one group of things I now know how to integrate. Second technique is u-subs, right? U-substitution. That allows us a big chunk of new things that we can integrate, and that's really useful. But that doesn't cover everything in the universe. So we are now going to add to that by giving you various other techniques that will allow us to find the antiderivative, right? It will allow us to integrate other functions. Now, u-subs and standard integrals and power rule are very big and get used a lot. The ones that you're now going to learn are going to become less frequent. They are useful for what they do, but you don't do them so much as you do the other techniques. I guess that's what I'm trying to say. Well, let's look at the first one, 7.1, called integration by parts. It's essentially the product rule for integration. So how do you integrate a function if it's made up of two things like x squared e to the x, 2x cosine x, things like that? How do you actually integrate a product? And there are two techniques, two methods, both work. They're both called the integration by parts. The version I'm going to show you is this one. And it says that the integral of f of x g of x is equal to f of x times the antiderivative of gx, take away the derivative of f times the antiderivative of g of x. And that's what that is saying here. So the process of doing this essential product rule for integration has a formula to it. The other technique is called UDV, and I've got videos in Canvas to show you that technique. I don't know why in America UDV seems to be the go-to guy, but it might be everybody was taught that way so that when they become professors, they teach it that way. Well, when I went to university, I was taught this way, and I will now use this way as my go-to technique. They are totally equivalent. They both give you the same answer at the end. If you do not like this formula, then feel free to do your homework using the UDV method, and it is fine. I personally don't like the UDV method myself. It just looks weird. I don't know why it looks weird to me, but it just looks weird. This I like because to me it's a formula, right? This guy goes here, that guy goes there, and it's relatively straightforward what guy goes where. Now, one of the things you're going to discover as we go through these questions is that this is not quite as easy as Calc 1 product rule. In Calc 1, didn't you just do f dash g plus f of g dashed? You plugged in the things and you were finished. All that was left was algebra and make it look pretty, but you were finished. Have you noticed that this formula still has an integral? Which means that it's not that uncommon that when you do the integration by parts method, that this integral, you have to do integration by parts a second time or even a third time before it's finished. So step one, choose f of x and g of x. Well, you might say, hey, that doesn't even need to be a step. The first one's f and the second one's g. Obvious. Sorry, not obvious. There is very often, there is a correct choice, one that works, and there is a wrong choice, one that doesn't work. Now, you'll know the one that doesn't work if you pick it within 2 lines of working, you're going to be looking at something and saying, that ain't happening. That has just got uglier. You know, this bit over here has got uglier, or I don't know how to fix it, or I don't even know where to go next. If that happens, then you start again and you switch places. But it's helpful if you know, just like picking USUBs, there are some features that you can look for that tells you how to do it. So let's practice just showing you how step 1 works. If your function is a power of x and e to the x, right? Your function and an exponential, then that guy's f and that guy's g. I won't bother put the integrals now. Now, if it's a power of x and a trig function, like sine x or cosine x, or for that matter, secant squared x, again, pick them as your f and pick the other one as your g. But if it's an x squared log x, or any power of x and log x, and that includes square root of x and cube root of x, right? Any power at all of x with a log x, right? If you ever see that, the log is your f, and the x squared will be your g. Okay. If you ever see a combination of e to the x's with a trig function, and the answer's dead easy. Pick them in any order. You can make either of them f or either of them g. Both ways work. Just be consistent. So do you see there are choices going on here, at least in some cases? Now, in general then, if you have a function called f of x and g of x, because there's lots of combinations, I can't go through every permutation. The list would get so big it would be impossible to memorize them all. So here's a general truth that you can use in almost every situation. If you can't integrate one of them, make that function your f of x. So if you can't integrate the first one, right, make that your f of x. If you can't integrate the second one, make that your f of x. So what would that look like? Suppose someone went and said to you, x inverse tan of x. Do you know how to integrate inverse tan of x? And the answer is no. Right? Doesn't exist. You might be saying 1 over 1 plus x squared. That's not the integral, that's the derivative. So make him your f, make him your g. You see how that's going to work? It's a general rule. If you're multiplying two things, one of them's going to be f, the other's going to be g. If you can't integrate one, then make that the function, your f of x. And the second part, if you can integrate both, pick your f of x so that f dashed of x is simpler. So what do I mean by that? Well, can you imagine you've got powers of x as the most classic example. Can you imagine you've got an x cubed and some other function, right? And we could integrate the other function as well, right? And we could differentiate the other function, right? I would pick x cubed because if you differentiate x cubed, isn't 3x squared simpler? Now, can I differentiate the inverse sine of x? Suppose that was a different story. Yeah, I could differentiate the inverse sine of x, but isn't the derivative of the inverse sine of x even uglier? Because it's 1 over the square root of 1 minus x squared. So when you're looking at a function and you know that you could use either one as your f or your g, think to yourself, which one of these two is likely to be simpler? Right? So x cubed becomes x squared. That's what I would consider simpler. Well, I think it's time we actually did one. Well, not yet. I want to show you this. I think I touched on it once before, but I want to show you again because it's going to save you a heck of a lot of time. I'm going to show you a little side thing, and it's the linear shortcut method for integrating trig and exponential. Opens. If I asked you to integrate e to the power of 4x, couldn't you do a u sub 4x and get the answer? Can I tell you that the answer will be that plus c? If you integrate e to the 3x, the answer will be that. If you integrate e to the 2x plus 7, the answer will be that. This is the linear shortcut method. When you integrate e to the 4x, you do get e to the 4x. Do you notice that you also get a quarter or a third or a half? And doesn't that come from the 4x, the 3x, and the 2x? What that means is that if I have to integrate this guy, I can immediately write this down without having to grab another piece of paper and do a u sub at the side and work my way through the u sub to eventually get the same result. What would the integral of sine 5x get me? Well, a sine gets you a negative cosine. What will the 5x get me? It's going to go here where my finger is pointing.
1/5.
And if you want to find the integral of, say, this guy, well, a cosine gets me a sine. And what else will I get?
Or 1/2.
You can do it for things like this as well. Because isn't the integral of a secant squared a tangent? And won't the 5x minus 2 get me a fifth? Have you seen that this shortcut just cuts down your workload? Because if you can do this shortcut, don't you know the answer without having to do a whole load of u subs and work your way through? And so we're going to, from time to time, we are going to come across situations where this little shortcut is going to save us, 5 minutes or whatever. And that's cool, right? Saving time. Now, if this is just, I can't remember that, it don't make sense to me. Well, just do it with u subs. There's nothing wrong in doing u subs. I'm just trying to show you a way of avoiding it. So now we are ready. There's our first example where we need to use integration by parts. If you look at that really carefully, do you notice that a u sub doesn't work? Agreed? U sub does not work. So I'm going to do the integral. So I'm going to do f of x, capital G of x, take away the integral of f dashed x, capital G of x, dx. Okay, step one. Which one of these two is going to be my f of x? Is it going to be the x or the e to the 3x? Which one's it going to be?
E to 3x as g and x as f.
Great. If you look back at my list, didn't I say, look, if it's x cubed e to the something, x squared e to the something, don't you pick x squared as your f? Now, see what that becomes. F of x, which means you leave that alone. Now, g of x, capital G of x, is the integral of e to the 3x. Can you see how the linear shortcut's going to save us some time here? What is the integral of e to the 3x then? Oh,
1/3
yeah.
e to the 3x.
Yeah, I was worried for a minute. Right, take away the integral of the derivative, which is 1, times capital G of x, which we already know is this guy. I tend to spend a line tidying things up, so that's all I'm doing here. Now, do you notice that in this case here, aren't you just left with an integral? But isn't this integral doable, right? It's not that hard to get the answer to it. So let's finish it off then. If you integrate 1/3 e to the 3x, you will get, technically, won't you get 1/3 e to the 3x times something, times another third. And that's why this is a 9th. Are you happy about where that 1/9 has came from? Right, this 1/3, an extra 1/3, 1/9. This is the antiderivative of that. If you differentiate this, trust me, that's what you end up with. So it's quite impressive, the person who came up with this. Actually, the proof of it is that they just used the product rule, but worked backwards. And that's where this formula came from, if you're interested. Okay, let's try the next one. A little bit trickier. So I have an x squared and I have a cosine x. One of these two guys has to become my f of x. I like to focus on who the f of x is because the other guy's g, wants to know f. So who's f of x going to be in this story?
X squared.
Great. So leave it alone, x squared. Integrate this guy, positive sine x. Take away the integral of, differentiate this guy, 2x. Integrate the other guy, positive sine x dx. This is why integration by parts is a process rather than a formula. Do you see that what we're left with is an integral that we need to use integration by parts on? So who is going to be the new, I'll put a bracket around it. Who's going to be the new integration by parts? Which one of these is f?
2x?
Yeah. I won't bother writing the formula down this second time. That just takes up too much time. But can you imagine that I have written it down? So it's going to be take away. So it's going to be leave that guy alone. And then integrate sine x, which is negative cosine x. Subtract the integral. Differentiate this guy as 2. And integrate this guy, and you get negative cosine x dx. And I'm now going to tidy this up. because it's negative all of this, and that's pretty messy. And if I kind of did it, I'd probably lose a sign. So the negative of this becomes plus, so I get that. This is negative, then you subtract it, and then inside the integral, you've got yet a third negative. So the negative of a third negative makes this negative. And I think this line to here is important for me anyway, and hopefully you can see the advantage. And I'm going to finish this question, and then it looks like my dogs need something, and my wife is at the college right now, so she can't do it. So if you can bear with me for a few seconds while I finish this fella off. Right, antiderivative of 2 cosine x. I don't need integration by parts for that, agreed? Isn't that just 2 sine x with a minus next to it? So negative 2 sine x plus c. Okay. Now, since I'm going to have to do something with my dog, let's give you a little challenge. I want you to try and find and I'll be back in a few moments. Well, I'm back. I was quite sneaky there. Do you know I gave you a puzzle where the first stage picking the right f and it goes easy. And if you pick the wrong one, it's pretty clear quite quickly that it isn't working. There's only one correct choice of f here. Which function?
ln of x.
ln of x?
Yeah, correct. And this one comes under the category. If you can't integrate something, make that your f of x. Do you know we do not know the integral for log x? You agree? I know the derivative of log x, but I do not know what its integral is. So that's the guy that we're going to use. So it's going to be f of x, which is basically log x, g of x, which is this guy, which is a power rule, take away the integral. Well, the integral of log x is 1 over x, and the capital G is, again, a 1/3 cube of x. But then something really nice happens. Won't this x cubed partially cancel with this x on the bottom? And now we're left with 1/3 x squared. The log has miraculously left the building. Ain't a problem. Add 1 to the power. Done. There is something just elegant about this, isn't there? There's something kind of like almost magical of, wow, that was cool the way that disappeared. So let's try a different version of that question. Uh-oh. It's not log x. We just did that one. It's log x all being squared. You know that doesn't change who I pick for f and g. Right. If I don't know how to integrate log, I certainly don't know how to do log squared or log cubed or anything else in that family. So we're going to do f of x, which is that, capital G, take away f dashed. Isn't the derivative of log x all being squared a chain rule? So when you differentiate log x all being squared, it's 2 lots of log x times the derivative of log x. You see, you get a 1 over x out of it. Multiplied by the capital G guy, which is this. So we now have 1/3 x cubed, the natural log of x squared. Take away, cancel one of these x's, put these guys together, and I end up with 2/3 x squared log x dx. Have you noticed that the original integral has now changed into a simpler version of itself? Now, I'm not going to do this any further, except to say, isn't this question basically this question? So to complete this, wouldn't you make this guy f and this whole mess here g, and dot 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 until you're finished? So this integration by parts has now expanded functions that can be integrated. We can now at least have an attempt at a function that's really made up of 2 things multiplied together. Well, that's cool. So here's a question that looks superficially impossible. Log x on its own. Log x on its own. Now, we're going to use integration by parts, but for integration by parts, I need two things, right? Something times something, right? And right now, I've just got one thing. Is there a workaround for that? Yes.
Can it be 1 times it?
That's the workaround. Now, I still have to pick an f of x, don't I? Isn't it going to be the same f of x as the other two? That makes this 1 g of x. Okay. So what do we get? We get f of x, which is the natural log of x, multiplied by the integral of 1, which is x, take away the integral of the derivative of log x, which is 1 over x, times the integral of 1, which is still x, dx. And it now ends up being x log x, take away the integral of 1, and that is x log x, take away x, I'd say. So we now know who he is. So when I started today, I kept on saying, look, you don't know who ln x of is, right? That's why you had to pick him as your f. Actually, we now do know what ln x is, isn't it? It's that guy. But when you're asking yourself the question, who to pick, well, you pretend you don't know the integral of log x. It'll just make your life so much simpler, right? So pick it as if you never knew what it is. Now, this trick of doing 1 times is really cool. I'm now going to find the integral of the inverse sine of x. And no, the answer is not 1 over 1 minus x squared. That's what the derivative of the inverse sine x is. But it's antiderivative, right? It's integral. We don't know. You know I'm going to call it 1 times again, aren't I? That's how you do all single functions that you don't know. 1 times. And I'm going to pick who as my f of x.
Sine inverse.
Remember my rule at the beginning of today, if you don't know how to integrate it, make it your f of x. That's the rule I'm using. Now, this is going to equal f of x. Well, that's the inverse sine of x times the integral of 1. Take away the derivative of inverse sine of x. Okay. Oh, well, I already mentioned it, didn't I? What's the derivative of the inverse sine of x? There's the start for you. 1 over
1 minus x squared.
with a square root around it.
Ah.
Right? Times big G. Well, the integral of 1 is x. So we now have x times inverse sine of x. Take away the integral of x over this ugly guy. Now, superficially, you might say, oh, darn it, dead end, we're stuck. No, we're not stuck. But it's not integration by parts that's going to get us out of this hole. What strategy do I use to integrate this fella?
U sub.
And somewhere at the side, you're going to do that as your U sub. And can I just say dot, 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 and you'd finish it off in the usual way, and you'd be done. Techniques for integration aren't little boxes where only one thing happens. Can you see in this question, it was an integration by parts that then needed a U sub to finish it off. There are situations where you do a U sub, and then the result you get needs an integration by parts to finish it off. So you see how the two methods can sometimes interconnect with each other, right? I don't think you've ever seen one, but it's possible. Do you know you can do a U sub and then have to do a different U sub to finish the question? So the first U sub turns it into this guy, but this guy needs a different U sub, you know, I'll call it a W sub to finish it. That's a pretty rare, but I have seen that happen.
Yeah, we did that. I think I have that in my notes somewhere.
Right, so it can be done, right? So integration by parts followed by integration by parts is very common. That happens a lot. Integration by parts with a U sub after it, now and again. U sub first and then an integration by parts, yeah, now and again. But all combinations are possible. Are we good? I've been doing math for a long time, and it just came to me. I don't think I've ever seen a question that I started with an integration by parts. I needed a U sub, and then the U sub turned into a question that I then needed to do a different integration by parts. But I'm sure there is a function out there where that weird combination might happen, right? You are never going to see one. At least I've never seen one in 40 years of teaching, but theoretically it could happen, right? So I just want you to be okay with that when it does happen, right? That you can use one technique followed by another. So let's go back to logs. I like logs because they generate some quite interesting questions. We already did the log x guy. Let's look at this puzzle. The thing that stares at me, that gets me worried, would you agree that square root of x inside a log doesn't look good for integration? You agree? So I think about it and I wonder if there's some other way of rewriting that that's equivalent, that maybe takes care of it. Well, if I call the square root of x, x to the half, does that give you an idea of where I'm going to go next? How can you write the natural log of x to the half?
You can pull out the power, right?
Correct. Now, when you look at it like that, isn't that basically the log function with a half in front of it that we've done earlier? But that's now f, and the half is the g. Just to show you, not every question is ready to be used, right? Some questions you have to do some stuff. This will be the last one for today. And this one is going to hurt your head. The way it's written is not very helpful, agreed? If I'm going to use integration by parts. Any suggestions how to work with it?
So if you pull out the 1/2 power on top, the 2 will go to the bottom. So this will become 2x to the 1/2 power, and you can bring that up as a negative exponent.
Do y'all get that? That's actually x to the half, but it becomes x to the negative a half. That half power comes out like this. Now in this world, I better write that because it's so crunched. There, that's a much cleaner version of what I wrote, right? Now in this world, Won't log still be the F, and won't this mess be my G? And off you go. And that is a very sensible approach to that question. It's also not the only approach.
Can't you do U sub for square root of X?
Yes, if you do what she just said, can you trust me that it ends up being that guy?
Yeah.
If you do a U sub, right, which basically means call it x to the half and off you go and do your stuff, right? Now, isn't that guy pretty much, if you replace the U with an X, haven't we already done that guy? And at the end of the day, both methods will give you exactly the same answer. Now, I don't know myself whether the U sub and doing this or changing that and doing this is any easier or better than the other method. That's mostly a value judgment, right? Some of you like one method better than the other, and so that would be your method of choice. But they are both correct, and they both will yield exactly the same answer. So I don't care which one you say. Now, I can't think of a third way. There probably isn't a third way, but maybe occasionally there's going to be a question where there's 3 different ways to tackle it, right? You know, A, B, or C. And as long as they're mathematically correct, in other words, you get the right answer and you're doing things that are mathematically allowed, then go for it. You might come up with a rather sneaky shortcut to a question. That's kind of cool when you do that. I have done this, true story. I taught a student once who was phenomenally good. I mean, best student in math I've ever taught. We were doing some Calc 4 stuff, and I was doing a big, long, horrible partial differential equation thing, right? Really massive. It took about 10 minutes to do. Took like 2 pages of paper, done the whole thing, got the right answer, which is a freak because normally I screw up, but I got the right answer. I was kind of pleased. And he just said, do you know if you did this and that, it became a 3-line question? And I just looked at it and I thought, I wish I had that brain. Right? Some people just got that natural math flair that they look at things. So when you look at this question, I don't know who went and suggested the U sub. Was that where you were thinking before I did this?
Yeah. Yeah, I was just being quiet, sorry.
No, that's cool. That was, I like the insight. That would have been a different choice. Me personally, and that's nothing to fault what you said, I probably would have done this, mostly because my brain was thinking in this question, right? So this question was still in my brain. So when I saw this one, I was thinking of using this technique. But sometimes it's a good idea just to go away for 2 minutes and come back and then look at the question fresh and say, I wonder if there's another way of tackling this, because the way I want to do it's going to take forever. Maybe there's a better way, quicker way.